Okay, so rule number one. Rule number one. There are only 7 strong acids. Okay, so these are the 7 strong acids. And then for your strong base, okay, it has to be column 1, column 2, oxide, hydroxide, and hydride. Okay, so when I say oxide, it's actually it's metal, go with oxygen. Hydroxide is actually metal, go with OH. Hydride is actually metal, go with your H. If you see your 1A, 2A group associated with oxide, hydroxide, or hydride, strong base. All the others, weak base. The rule number 2. Rule number 2 is actually this table. So you can see I highlight a periodic table here, right? And I draw certain arrows. If you have a chemical structure that goes down to the table or goes to the right to the table, it will be more acidic. For the base, it's actually if you go more down and more to the left, it will be a stronger base. Let's say, so if you look at this for now. If today I have acid, okay, I have HF, HCl, HBr, and HI. And then I ask you, rank these 4 different acids based on their acidity. Which one is actually the strongest? HI, right? If you know these rules, it's very easy for you to answer these questions. Another example. If today I focus on this, if I have NH3, H2O, HF. Okay, if I give you 3 chemical formula, which one is actually a stronger acid? HF, right? So how do you actually know that? Because you need to actually recognize the connection between the 3 different species actually belongs to the same role. Right? If you go to the right, it becomes more acidic. Okay, so you know. All right. Okay, the same concept is here. Okay, so if today I have NaOH, KOH, RbOH, which one is actually a stronger base? Right, because that's actually the one at the most bottom, right? So you know that should be the answer. Okay. And again, if you have NaH, Mg, H2, Al, H3. Which one is actually a stronger base? Should be this, right? Because the things we're actually highlighting is actually this row, right? So if you go to the left, then you know it's actually a stronger base. So let's actually our rule number 2 and number 3, right? One is for acid, one is for base. Okay. Rule number 4. Okay, so I should say rule number 2 and number 3, which is actually one for acid, one for base. Rule number 4. If today you have oxalic acid, then you can further judge based on the differences between number of oxygen atom and the hydrogen atom. If you have a larger differences, then you have a stronger acid. The very, very standard question is actually this. How do you actually judge this? This is where you're going to use the rule number 4. Okay, what you do is actually you calculate number of oxygen minus number of hydrogen. Whoever gives you the larger number, then it is actually a stronger acid. So in this case, if you look at this, HClO4, number of oxygen equals to 4, number of hydrogen equals to 1. Therefore, you know this is give you a number of 3. And then you look at this gives you a number of 2, this gives you a number of 1, this gives you a number of 0. So in this case, then you know the acidity to arrange in this way. Can you judge the relative acidity of these 3 different species? I hope the answer will be yes. Okay, very similar thing. So that is actually basically the 4 different rules that we want to know. Okay, make sure you actually memorize these rules. Another very, very important thing is that one thing that students get so confused is actually every time when they see this type of acids. Because one thing you are going to get tested a lot is so-called sometimes you will see this terminology is actually inside your homework and also inside your textbook. You'll see this monoprotic, biprotic, or triprotic acid. Monoprotic acid means actually it is the acid when you throw it into water, it's going to produce just 1 proton. What is the most famous example of monoprotic acid? HCl, yes, that's actually the monoprotic acid. What else? HF, okay, monoprotic acid. HBr, HI. How about HNO3? Okay, monoprotic. How about HClO4? The simplest rule is actually, if in the formula it only contains 1 proton, it has to be a monoprotic. Okay, so HClO4, monoprotic, biprotic, or triprotic? Monoprotic, okay? Okay, so those are the easy ones. What are the difficult ones? Let me ask you. Okay, so I give you 3 different acids here, right? One of them is monoprotic. One of them is biprotic. One of them is actually triprotic. Which one is which? Okay, it's hard to guess, right? If you really want to understand these things better, the easiest way is actually you know the structure. So I'm going to provide a structure for you, then you can actually make a judgment. H3PO2. Let's start from H3PO4. Okay, it looks like this. H3PO3 look like this, and then H3PO4 look like this. So remember in the very beginning when I say, okay, if you look at the acid, for the organic acid, you must looking for the COOH, right? It is the proton associated with the oxygen, okay, that eventually become protons. So the OH is actually a minimum requirement for you to actually produce protons. Okay, with this concept, then you can actually see these things more clearly. Now look at this. Remember, the OH is the minimum requirement. Then you can actually produce protons, right? If you look at these 3 chemical formula now, can you predict which one is actually monoprotic, which one is actually biprotic, which one is actually triprotic? How many OH you have in this one? 1. So it has to be monopodic. Okay, how about the second one? How many OH you have? 2, right? So this is actually the bipodic. How about this one? 3, right? Tripodic. You are going to see many examples in your homework, okay? It's actually all the same. Okay, so the way you make the judgment is actually, okay, I draw out the chemical structure. Then I have no problem to identify who is actually monopodic, bipodic, and tripodic. All right? So it's actually something that you want to actually pay attention to it because it's very important that you summarize the table to actually clear these things out. Okay? So this is actually one of the most important examples you're going to see in this chapter, okay? That probably is actually the most difficult ones. So if you see similar things, then apply the same thought. Then you should be able to actually address those questions easily. Clear? Good. So trying to make a table, okay, yourself, okay? And then write down, okay, the acid you feel confused. Put it into this table, then you will be fine.